And the topic of today is understanding some basic statistic and a descriptive analysis for quantitative research. So, in basic statistic, also preparing your data for analysis is some part that today I will try to cover. But if you watch videos, I will go a bit faster. And if you have any question, you can stop me and ask your question. Okay. As before I mentioned, we have there is one way to categorize different types of analysis, but actually some scholars are not very agreed with this categorization and put different types of analysis that we use under multivariate. But also we can accept this categorization and go with these three categories: univariate, bivariate, and multivariate analysis technique. So under analysis technique, actually we have these three categories. A univariate refers to some descriptive analysis. Today I will try to go through some descriptive analysis. And the univariate actually is some analysis technique that we apply only for one variable. So when we are working with one variable and do some analysis and use some statistic for one variable, these can be categorized, these techniques can be categorized under univariate analysis technique. But bivariate analysis technique is some for cases that we apply more than one variable. We apply two variables, right? So we see the relationship between two variables and check the relationship between two variables, difference between two different situations. When two variables involve in our analysis technique, so these can be categorized, these techniques can be categorized under bivariate. And multivariate is for some cases and some techniques that we apply for more than two variables. So in analysis, actually more than two variables are involved in analysis. So there are many different analysis techniques under multivariate, and especially for social science, multivariate is very common, and can say most common analysis techniques are multivariate analysis technique that we apply to address our objective and to test our hypothesis. Okay. Under univariate or descriptive analysis, we have actually the three basic concepts under descriptive statistics, especially when we are working with the continuous variable or ordinal variable. And the continuous variable means interval, ratio, or scale variables. These three basic concepts are mean, median, and mode. We call these three concepts actually central tendency measures. We, based on these three concepts, basic concepts, we can understand behavior of our variable. Actually, for example, when you collect data for from 400 respondents for measuring intention or for measuring satisfaction, for example, you cannot understand the satisfaction of all these people when you go through each case one by one. So you need some measure, you need some parameters to understand the overall satisfaction of these 400 respondents, 400 cases. Or you want to understand behavior of 300 respondents about purchasing a product, right? So some of them are willing to purchase this product, but some of them are not willing to purchase this product. So you cannot understand the behavior of these 300 respondent or 300 cases by checking one by one the responses. So you need some measure, you need some parameters to understand overall behavior of these 300 respondents, 300 samples, 300 people, right? So mean is one of the most common parameter or measure actually that we use to understand the behavior of variables, to understand satisfaction, to understand attitude, to understand the intention to purchase, right? So what's the mean? What's the mean? Mean of mean? Mean or average actually, when we can get with the calculating simple average of all responses. So this will be mean value for all responses that we have. For example, if we have 4 responses, 1, 2, second one is 4, and third one is 7. So mean value means average of these 4 cases. So the average is 3.5. So this is mean value of these 4 responses. If, for example, we have, we measure satisfaction based on 5 point Likert scale between 1 to 5. 1 refer to strongly dissatisfied, and 5 is strongly satisfied, right? And we have something between this 1 to 5. And we have these answers from 300 respondents. So for first respondent, for example, the answer is 4. For second respondent is 3, 5, 2, 1, 3, 4. So when we get average of these 300 respondents, for example, the average is 4.5. 4.5. So this is the average of these 300 responses. This 4.5, what show to us? This 4.5 number show most of respondents are satisfied, because this number is very close to strongly satisfied. So this average or this mean value show the overall behavior of satisfaction. So show overall satisfaction. If this value is 2.1, so it means it's very close to strongly dissatisfied. So based on this value, based on this mean value, we can understand most of the respondents are not satisfied. So this mean value is a parameter that actually can show us the overall behavior of our variable, right? What's median? Median is the middle number. For example, if we have these 4 answers, or we have 5 answers, 1, 2, 4, 2, 1, 2, 4, 5, and 7. So we have 5 answers. So what's the middle number? Middle number is 4. So median is middle number. If we have 2 middle number, so the number is even. So we have 1, 2, 5, 7. So median will be average of these 2 middle number. So will be 2 plus 5 divided to 2. So median is 3.5. And mod is the most repeated number in our sample, our responses. For example, if we have 1, 2, 2, 3, 3, 2, 4, 5, 1, 3. So we have these responses for 10 respondents. What's the mode for these responses? What's the mode for this data set? Is 2, right? Because 2 repeated 3 times, and also 3 repeated 3 times. So we have 2 modes. We have 2 modes for this one, for this data set, right? And 2 modes, we have 2 numbers with same repeated numbers, right? So mode for this one is 2 and 3. But if we delete this one, delete this last 3, so among these 9 responses, mode is 2, right? So this is the 3 basic central tendency parameters that actually can give an overview or understanding of our variable and our respondent and the data set. So if we have a large number of data, how we calculate the mean? For example, if we have x1 to x300, so we have 300 samples. So mean value that we show with x bar is x1 plus x2 plus x until x300 divided to 300. So this is the average or mean of these 300 values. Okay. Another basic concept in to understand a variable is standard deviation. Standard deviation and then variance are 2 very really important parameters to understand the behavior of variable and pattern of variable. Standard deviation actually also is showed by sigma for population or S for standard deviation of sample, is a parameter, is a measure that show variation of data set. How our data varies from one case to another case. What's the varied answer? What's the varied responses? What's the varied values for this data set, for this variable? This is the formula to calculate standard deviation. But to understand this standard deviation, for example, we have again, we have satisfaction. Okay, we have satisfaction for 300 respondents. So satisfaction for first case is, for example, 2, second case is 3, and the third case is 5. So it's continue to 300. Satisfaction 300 is 4, for example, right? So by calculating the standard error, standard deviation, we can see what's the variation between different answers. How different answers change for different respondents and cases. If the standard deviation is high, it means we have varied responses. We have 2, we have 3, we have 4, and we have repeated 2. Many respondents answer 2, and many respondents answer 3, 4, 5. So we have varied answer. This variation can be calculated using this formula for a standard error. So, for example, if we have satisfaction and the standard error of satisfaction is high, when we want to see effect of other variable, satisfaction, for example, on loyalty, right? And we have high standard deviation also for loyalty. So we can actually measure loyalty when satisfaction change, because we have good variation in satisfaction, and also we have good variation in loyalty. But let's say the standard deviation, the variation of answers for satisfaction is very low. Most of respondents only answer 4 and 5. So the standard deviation is very low, because look at the formula of standard deviation: x minus x bar, that is the mean value, power of 2, summation of this, and the square root of divided to n minus 1. N is number of sample minus 1. So this is standard deviation. So if x and x bar is very, very close, so all answers are very close to mean value, so means this standard deviation is very low. When a standard deviation is very low, the variation, the changes of answers are very low. So it means we cannot see changes of this, for example, satisfaction to loyalty. So when a standard deviation of satisfaction is very low, so it means we cannot see the behavior of satisfaction or the effect of satisfaction, relationship between satisfaction and loyalty, because we don't have much changes. We don't have varied answer for satisfaction. So we cannot see what happened when satisfaction changed. What happened to loyalty level of respondent when satisfaction changed. To understand this relationship, we need to have good changes, variation of answers. And this variation of answers is represented and calculated by standard deviation and variance. So a standard deviation to the power of 2 squared of standard deviation is variance. So variance is one of the key parameters for bivariate and multivariate analysis. If we don't understand the concept of variance, and before that the concept of standard deviation, changes of variable for different cases, so it's not possible to understand the meaning of many of multivariate analysis techniques. So variance is key, and variance refers to variation of answers for one specific variable, right? So you can see the amount of variation of a data set. How varied, what's actually the level of variation, changes and differences between different answers. Okay, so this is the concept of standard deviation and variance. So this is the formula again for standard deviation and for variance, but for variance of sample and variance of population. There is a big difference between variance of sample and population. If we calculate variance of sample, here we include the mean value of sample. And here we have n-1. But if we calculate variance of population, mu here is mean value of population, not sample. And we need to include n. N is number of population members, right? So this is the formula for calculating variance of sample and population. Okay, any question for this one?